When we look at the value-added charts, we'll notice that there are varying levels of evidence of growth. Let's take a look at an example of a couple of the reports. Here we're looking at two value-added reports, a gain model at the top and a predictive model here at the bottom. But what we're focusing on today is the color coding that takes place on these reports. Now we've talked about the numbers, where for example, the 1.8 comes from. And we've talked about the standard error, how that's calculated, but we didn't really talk yet about the color coding that's used to show the evidence of growth. So that's what we'll talk about. We'll use this example right in here as our first one. We'll notice that they have color-coded this a light green, and the LG stands for light green, the DG stands for dark green, Y for yellow, R for red, and O for orange. So we're going to look at this one. This has a growth of 1.7 and a standard error of 1.2. Now we haven't really talked about applying that 1.2 to the 1.7 growth measure. So let's do that. Here we plot the 1.7 on a line graph. The 1.7 is the growth measure. That's well above the growth standard of 0. That's kind of always our standard, is to at least maintain our relative position or meet our predicted scaled scores, our average scaled scores. So now let's apply the standard error to this 1.7. With the 1.7, with a standard error 1.2, that means that we can add and subtract the 1.2 to and from the 1.7. That'll take us up to a 2.9 and down to a 0.5. That's one standard error. That's giving us that measure of confidence in our 1.7. We know that based on the number of students and some other factors that 1.7 could have been as high as 2.9 and down as low as 0.5 with a standard error of 1.2. If we take it 2 standard errors above the value, we could go up as high as a 4.6 and down as low as a negative 0.7. Notice that the 0.7 then falls below the growth standard of 0. That's important when they determine the colors. So let's take a look at the color coding chart. If we were to measure our growth and within 2 standard errors, they both, adding and subtracting the standard error, both values fall above the growth standard of 0, then the color coding for that would be a DG, or dark green, and that's indicating that there's significant evidence of growth for this group of students, this school, this subject, whichever the calculations imply. When we look at the values which we just had as our sample, the 1.7, 1.2 standard error, we notice that with 2 standard errors, it dipped just below the growth standard, right in there. Well, that's still indicating there's a lot of evidence to support that growth was met. This whole section, 1 standard error completely above the growth standard, and the other part just dipping just below the growth standard. That's light green. That's moderate evidence. Let's take it a little further and you'll start to see when the growth standard of 0 falls between 1 standard error below and 1 standard error above, as it does in this example. As long as that growth measure falls between those 2 standard errors, the values for 1, that's going to be color coded as yellow. That's indicating that we met growth. We met the growth standard. We are within a standard error of meeting that growth standard. So these first 3, that's significant evidence, moderate evidence, and they maintain their relative position. There's evidence of growth. Those are all positives. Then we start getting into the ones where there's moderate evidence that the students fell behind, and that's because the growth measure is more than one standard error below the growth measure. Even though with two standard errors, there's a chance that it's above the growth measure of 0, there's significant evidence that it's below, or I'm sorry, in this case it's moderate evidence. When they are both below, as they are in this final example, that's the significant evidence that the students did not meet growth. They fell behind their peers. So you can kind of see it's all the color coding is just based on the evidence of how confident we are in that growth measure. Up to and including 2 standard errors of the growth measure, which would represent a pretty accurate calculation. So let's do another example. In this model, we see the growth measure of 1.5 with a standard error of 0.5. So this is a simple adding and subtracting 0.5 to our measured growth value, the measured growth measure of 1.5. So one standard error takes us up to 2 and down as low as a 1, clearly above the growth measure, standard growth of 0, that goal. When we use 2 standard errors, we drop down to 0.5 and up as high as 2.5, still clearly above the growth standard of 0. So the color coding for that would be the dark green. With this model, the growth measure came out to be negative 0.7. The students lost ground. How confident are we in that? With a standard error is 0.6. So in this case, we go 0.6 below the measured growth and 0.6 above. So we end up going to as far as negative 1.3 and as high as negative 0.1. The one standard error falls below the growth standard of 0. But when we use 2 standard errors, we go as low as negative 1.9, but as high as 0.5. Because 2 standard errors goes above the growth standard of 0, there's still a within 2 standard error chance that this group actually did show growth. So that falls into the orange. Even though 1 standard error is below, there's still a small amount of chance that that group met the growth. So that's why they're color-coded orange in this case. Red would have represented that the 2 standard error line would have also fallen below. When we look at the actual charts that are displayed in the EVAS value-added system, we see vertical versions of the same graph. They can be converted to horizontal, but they'll come out in vertical form most of the time. And they represent a last year data versus a 3-year average. We'll talk about that in an upcoming section. But what we're looking at here is where do we see these 1 standard error and 2 standard error whiskers, bar and whiskers, appear relative to the growth standard of 0. Well, for both of these, they're both clearly above the growth standard. If these were color-coded based on the 5 levels, this would be dark green. So would this next set. They're both above the growth standard, dark green. This one, we see 1 standard error above the growth standard, but the second standard error calculation falls below, and that would be our light green. It's still good evidence that they met growth, but not with 2 standard errors of confidence. The 3-year average is still dark green version, but in this case it's light green. With the group 4 that they're looking at here, and we'll talk about what the achievement group represent here when we get to that section. In this case, we see the 1 standard error, the growth standard falling right between 1 standard error above and below. That's yellow. The 3-year average with this one is dark green again. Here we see the same pattern where 1 standard error covers that growth standard of 0. And so that's going to be yellow again. And in this case, we see 1 standard error both of it, the higher and the lower values of that as compared to the growth measure, are both below 0. That's the 0 line. And so that puts us below what we have one standard error slightly above that still. So that would be the orange color. In order for it to be the red, both 1 and 2 standard errors would have to fall below the growth standard of 0. That's the basics for how they do the color coding on the charts that we'll see with the value-added reports.